There is a problem based on graph in thermodynamics. An ideal gas is taken through a cycle A to B to C to A to B to C to A. As a heat, that is net heat, is applied to the gas 5 joule. Then work done by the gas in the process C to A is how much? So let us do like these things. Work done from A to B equals to what? P into V2 minus V1. That is 10 into 2 minus 1 joule. That is equal to 10 joule. Work done from B to C is 0 because P into dV, as you know, constant volume is there. So work done will be 0. Now work done from C to A, that will be questionable. That is, we have to find out. Let it be X. Okay. So we know work done from A to B, work done from B to C plus work done from C to A equals to net, equals to total heat plus internal energy del U equal to del Q. So here we are getting 10 plus 0 plus X plus del U equal to del Q. What is that heat? Is 5 joule. But del U is 0 since it is a cyclic process. So 10 plus X equals to 5. So X equal to minus 5 joule. Now a question on thermodynamics. During an adiabatic process, pressure of a gas is found to be proportional to cube of its absolute temperature. The ratio of Cp by Cv for gas is 3 by 2, 4 by 3, 2 or 5 by 3. As we know, here according to the question, P varies as T cube. Again, according to the equation of adiabatic process, Pv to the power gamma equals to K. So in place of V, we know Pv equals to RT. So V equals to RT by P. So P into RT by P to the power gamma equals to constant. So what we are getting, P by E to the power gamma into R to the power gamma, T to the power gamma equals to K. So P to the power 1 minus gamma into T to the power gamma equal to constant K1. So here we can write P1 to the power 1 minus gamma into T1 to the power gamma equal to P2 to the power 1 minus gamma into T2 to the power gamma. So P1 by P2 to the power 1 minus gamma. As you know, gamma is a Cp by Cv. T2 by T1 to the power gamma. Here P varies as T cube. So P2 equals to, so we can write here P1 by P2 equals to, we can write T1 by T2 whole cube. Therefore T1 by T2 whole cube to the power 1 minus gamma equal to T2 by T1 to the power gamma. Therefore T1 by T2 to the power 3 minus 3 gamma equal to T2 by T1 to the power gamma. So same thing we can write it here, T2 by T1 to the power, just we can minus the power, that is 3 gamma minus 3. That means we can do like these things, 3 to the power 3 gamma minus 3 equal to gamma. So 2 gamma equals to 3, therefore gamma equals to 3 by 2. So the option 1 is correct. Now this problem is based on Carnot engines. A Carnot's reversible engine converts 1/6 of heat into work. When temperature of sink is reduced by 62 Kelvin, efficiency is doubled. What are the temperature of source and sink? Here is, you know, according to the question, W equal to Q1 by 6. What is Q1? Heat source, and Q2 is heat sink. So Q1 equal to Q2 plus W. So Q1 equal to Q2 plus Q1 by 6. So Q2 equal to Q1 minus Q1 by 6. That is 5 Q1 by 6. So T1 by T2 equal to Q1 by Q2. So it will give you Q1 by 5 Q1 by 6. That is, will give 6 by 5. So therefore T2 by T1 equal to 5 by 6. Now eta equals to 1 minus T2 by T1. That is an efficiency eta. That is equal to 1 minus 5 by 6. That is equal to 1 by 6. So according to the question, 1 minus, that is T2 is decreased by 62. 1 minus T2 minus 62 by T1 equal to twice its efficiency. That is 2 into 1 by 6. That is equal to 1/3. So T2 minus 62 by T1 equal to 1 minus 1/3. That is equal to 2/3. So 3T2 minus 186 equal to 2T1. So T2 equal to 5/6 of, again we know T2 equal to 5/6 of T1. So we put this equation here, 3 into 5 by 6 T1 minus 2 T1 equal to 186. Therefore 5 by 2 T1 minus 2 T1 equal to 186. So T1 by 2 equal to 186. So T1 equal to 372 Kelvin and T2 equal to 5/6 of T1. That is 5/6 of 372. That is equal to 310 Kelvin.